Hello and welcome to my third screencast of the Arithmetic Law. I'm going to cover the arithmetic identities of multiplication and division in the screencast. To start with, the multiplicative identity is 1. Any number we multiply 1 by won't change what that number is. So we call that the identity, the multiplicative identity. Now, it's important in finding the multiplicative inverse. Any number a, if we multiply it by its multiplicative inverse, will give us the multiplicative identity, which is 1. Now, the inverse of a to the power of negative 1, can also be written as 1 divided by a, or as a fraction 1 over a. Now, multiplication is commutative and associative, just like addition is. It's also distributive when combined with additions and subtractions, as shown previously in distributive law. Now, divisions, on the other hand, are neither commutative nor associative, but if you change the divisions into multiplications by using their multiplicative inverse, you can overcome the problem. So you can see here with this commutative law, and a divided by b does not equal b divided by a. But if you change the division of b into its multiplicative inverse, then you can use the commutative law. And the same follows with the associative law here, with a string of divisions. If you perform the division of the first two numbers first and then divide the third number into it, it does not equal the same as if you performed the division of the second and third number and then divided that into the first number. Now, if you change the division of b into its multiplicative inverse and the division of c into its multiplicative inverse, you can use the associative law. Now let's have a look at some examples. Now, in this example, I'm going to show you what not to do first. Now, the incorrect way of doing this would be to, for example, perform the multiplication of 4 and 5 before you do the division. So let's do that. So we have 2 multiplied by 3 divided by the multiplication of 4 and 5, which is 20. And that gives us, let's do it from left to right now, 2 times 3 is 6. 6 divided by 20, that's a fraction. I'm going to convert that into a fraction. Now, if we divide top and bottom by 2, we'll get 3/10, which is incorrect. Now I'm going to perform the calculation over here in the same order, only this time I'm going to use the multiplicative inverse. So I'm going to change the division of 4 into its multiplicative inverse. So we have 2 times 3 multiplied by the inverse of 4, which is a quarter, and then multiply that by 5. Now, same as in the previous example, I'm going to perform the third and fourth the calculation between the third and fourth element. So we have 2 times 3, and if we multiply a quarter by 5, we get 5 quarters. So that's multiplied by 5 quarters. Now we can simply multiply all of these numbers on the top together and divide them by 4. So 2 times 3 is 6, 6 times 5 is 30, 30 over 4. simplify that. 4 7s are 28, which leaves us with 2 quarters, which is a half. So the answer is 7.5. Now, in order to perform the first, if we do it without the multiplicative inverse, we need to follow left to right, and then we'll get the correct answer. 2 times 3 is 6. 6 divided by 4 is 6 quarters. 6 quarters multiplied by 5 is 30 quarters, and we will get the same answer of 7.5. Thank you.